Okay, so welcome to this live stream. We're going to be doing another SAT math question and answer session. If you're watching this on the replay, the playback, there's a lot of good value usually delivered in these live streams with commenters jumping in on the live stream, chatting and asking some really excellent questions. So, take a look at some of the problems that we're going to be going through here together, and then also pay attention to some of the questions that come later from the members that jump on the live chat and have some great questions. So I think what I'm going to do is just get right started into this live stream. Again, the way to get the most out of this, as usual, is just to ask questions and participate in the live stream as much as you can. And then another thing that you can do is help each other out. So I'm not able to maybe reply right away to a particular question, but if you can help each other out, you'll all get the best results from this live stream. So the other thing is, if everyone could just let me know, can you hear me okay? Can you see okay? Is everything all right? We're going to get started in just a second. We're going to do some 3 example problems I prepared for you, and then we're going to open it up for question and answers. So, okay, so we're sounding good. Okay, so welcome to everybody that's joined so far. Again, keep your questions in mind, and we're going to talk about some of these different problems. So I was working with a student just recently, and we were going through some problems together, and I know these are some problems that show up on the SAT exam, and so I just want to kind of show you, see if you can solve these. Okay, I'm going to start off by writing this first one down. So if 3y over 8x is equal to 5 over 6, right, what is the value, the value of x divided by y, question mark. So what do you think? So how would you solve this problem? See if you can do it on your own, and see what you get for an answer, and then go ahead and feel free to jump in here. What do you think we should do to solve this one? So this is basically, just an equation that they're giving us. They're telling us 3y over 8x equals 5/6, and they're asking us what's the value of x divided by y. Well, what do you think? Any ideas? Anybody has some suggestions what we should do? This is a typical problem, one that shows up a little bit earlier in the test. It's pretty straightforward, but sometimes it stumps students. It's in some type of form like this where they're asking you for a variation on what they're giving you here. So any ideas? Anybody want to jump in and let us know? What do you think you would do first to solve this? What's the value of x divided by y? Okay, Bob is saying, is it 0.45? Okay, what do you think? Is he right? Is Bob right? Well, let's take a look. So our goal here is to get y over x over y, but right now you can see we have y over x, right? So what I'm going to do is I'm going to flip the left side of the equation over. But if I do that to the left side, I have to do that to the right side, right? So that's just one of the properties of proportions. If you take the reciprocal of the left, you want to take the reciprocal of the right. Now, the thing is we want to end up with just this part right here, x divided by y, right? So how do we get rid of that 8/3? What do we have to do to get rid of the 8/3? Well, you could divide by 8/3, but sometimes it's easier just to multiply by the reciprocal. So I'm going to multiply both sides by 3/8. See how the 3's cancel and the 8's cancel, numerator and denominator? So now you can see we're looking at 18 over 40, which reduces down to what? 9 over 20, which equals what Bob was saying, 0.45. So that's exactly right. So yeah, good question. So as we're going through this, if you're just joining us, we're doing a Q&A, but I was just going to kick it off with some just some examples here, just some typical SAT questions. So the next one, that we're going to take a look at, let me go down here, is we're going to look at this one. So say they give you a compound inequality like this. They say if -3 is less than y is less than 5, right? And 4 is less than x is less than 7, okay, what are the possible, integer values of x minus y, question mark. So what do you think? So they're giving us 2 compound inequalities. If y is between -3 and 5, x is between 4 and 7, okay, not including -3 and 5, not including 4 and 7, right? What are the possible integer values of x minus y? So what we're looking for here, now a lot of times on the tests, there's a multiple choice section. They would give you some options and you could, check through them. But here I'm going to give you a hint. The answer is actually going to be an interval, okay, just like these are intervals. So we want to look at what is the smallest value that x minus y could be. And we also want to look at what the maximum or the largest value is. And then we know that x minus y has to be in between that minimum and maximum value. So let me ask you a question. What do you think the minimum value would be? What do you think the smallest that x minus y could be? So let's write this down here. So x minus y. Any ideas? Okay, Bob is saying 7. Okay, and he's got a question mark here. Well, let's see. The smallest value, okay, Seshi, if I'm not probably pronouncing that wrong, Proud is saying 6. Okay, good question. So what do you think? What's going to be the smallest value? Well, I'm going to give you a little hint. Okay, so you see the -3 here? See how y has to be greater than -3? So that means that this could, when we're talking about integer values, it can't equal -3. So the smallest this could be would really be like -2. The larger this y value could be as far as an integer goes is going to be +4. Same thing with x over here. The smallest it could be is 3. The largest it could be is 6. Now if you want to find the smallest value when you take the x's minus the y's, that's going to occur when you take the smallest value for x minus the largest value for y. So 3 minus 4, that's actually going to give us the smallest value of -1. Okay, Bob is asking, isn't the smallest x that can be is 5? Let's see, so x is between 4 and 7. Okay, and y is between -3 and 5. And we're looking for the integer values of x minus y, so the difference between x minus y. So the key is you want to take the smallest value here minus the largest value here. So 3 minus 4 is giving us -1. So now what's the maximum value that x minus y can be? What do you guys think? What's the largest that it could be? We're almost there. We've got our interval. We've got our smallest value here. We're trying to find our largest values here. Okay, Ceci is saying 4. Bob is saying, but 3 is not greater than -4. Oh, I'm sorry. Oh, Bob, I made a mistake. You're absolutely right. This is 5. Okay, whoops, I made a mistake. So you're right. So it's actually 5 minus 4 is +1. Okay, there you go. And let's see, Nail Lakani is saying the minimum value is +5. Okay, well, let's see. So to find the maximum value, you have to take the maximum over here, 6, minus the smallest value over here. 6 minus -2 is how much? It's going to be 8. Okay, so again, this was a tricky question, and we're getting a lot of comments in the comments box, and that's really good because the thing is, it's tricky. I mean, this is a tricky problem. A lot of students get this one wrong, but basically we're saying that x and y are integers. Okay, so we're starting with that assumption, and we're trying to find out what's the smallest that x minus y can be, what's the largest that x minus y can be, and then we're looking for the possible values, in between, okay, those two extremes. So the way you're going to get the smallest values, you're going to take the, what are you going to take here? To get the smallest value, you're going to take the smallest over here minus the largest over here. So we're doing x minus y. So 5 minus 4 is going to give us +1. And then to get the largest value, we're going to take the largest over here minus the smallest over here. So 6 minus -2 is giving us +8. So this was definitely a challenging problem. Go ahead and think about it a little bit more. But let's jump into the third question that I prepared for us today. And then remember, we're going to open this up for some Q&A. So if you have some other questions, we can talk about them here together. But okay, so this one, see if you can get this one. So they're going to give us a system of equations. You know systems, right? So systems is like 2 or more equations. And what we're going to do is we're going to solve this system. But what I'm going to do, I'm just going to kind of read this to you. We're going to find the value of C. Okay, this is C over here. So find the value of C such that the system has 2 solutions, right? Two answers, right? So what do you think? Go ahead and tackle that one. What would you do to solve for C, okay, this constant right here, so that when you solve this, you get actually 2 answers? Now, I'll give you some hints just when you're thinking about this. So first of all, this top equation, notice it's a quadratic. See, it's an x squared. So what type of a graph is an x squared? Okay, Bob is saying, would you do the discriminant and set greater than 0? That's exactly right, Bob, because we want to do the discriminant. Okay, plug x minus 1 in for y. Yeah, that's exactly right. Okay, so we're going to take the x minus 1, we're going to put it in for y, so that's a substitution method, right? So we've got x minus 1 equals 3x squared plus 2x plus c. What would you do from there? So Bob is telling us about the discriminant, and we did the substitution here. So what would you do next? Well, the next step, okay, when you do the discriminant, you want to get everything on one side of the equation and set it to 0. Okay, so that's right. Ceci's saying, get like terms. Yeah, that's exactly right. So you want to get everything on one side. So I'm going to subtract x from both sides. Okay, Bob says set it equal to 0. That's right. So that's going to be 3x squared. Subtract x from both sides. That's plus 1x. And then we're going to add 1, which is going to give us c plus 1. Now remember, when you do the discriminant, who remembers what the discriminant is? Do you remember the formula for the discriminant? Well, when you have an equation like this, right, ax squared plus bx plus c, the discriminant is actually what? There we go. Bob says b squared minus 4ac. Yeah, that's exactly right. So b squared minus 4ac. And if you want to... Okay, you guys still with me? Okay, so sorry about that. So basically, what we have to do now is we have to identify our a, b, and c. So we've got a is 3, b is positive 1, and c is this whole quantity, c plus 1. That's our constant, right? So what we've got is b squared is 1 squared minus 4 times a, which is 3, times our c value, which is c plus 1. And we want that to be greater than 0. Okay, so let's simplify this down a little bit more. Okay, and let's see, we've got 1 minus 12c minus 12 is greater than 0. Let's see, we've got negative 12c. What do we have? 1 minus 12 is negative 11. I'm going to add that to the other side, make that positive 11. And then now we have to solve for c. We're going to divide by negative 12. And is this going to be a greater than sign? Greater than or equal to, less than, or less than or equal to? See, the thing that they're testing us on in this question is that, yeah, less than, Bob says, because when you divide or multiply by a negative, remember that inequality, yep, Ceci says flip it, that's exactly right. So when you multiply or divide by negative, that inequality sign changes direction. Okay, and that's right. So Nail says c is less than negative 11/12. Yep, and that's exactly right, and that's what we're getting right here. So as long as c is less than that value, then you're going to get 2 solutions. So again, this was just testing us on the discriminant, and it was testing us on how to work with inequalities, and it was testing us on solving systems of equations. So 3 really good questions. If you understand those, I mean, those are going to be some easier questions to get right when you take the SAT. So who's taking the SAT coming up here on the 26th? Is everyone getting ready for the 26th exam? Yeah, who's taking it on the next? Okay, Ceci says she is. Okay, great, awesome. Very good. So one thing I wanted to let everyone know about, okay, Bob's taking October 7th. If you're preparing and you're looking for some additional help, I just wanted to let everybody know about my 2 courses. So I've got one course that's for the ACT and one for the SAT, and these are the math sections. So with the ACT one, I go through 65 concepts, and with the SAT one, I go through 39 concepts. So it's a video course, and you can check it out. There's 3 free previews for both courses. I've got a link in the description of this video. So if you go to the description, click on that link there, you can check it out and see if it's something that you'd be interested in. A lot of students have taken it and have told me that it's helped them boost their scores on the SAT. So definitely worth checking out. So go ahead and check the link in the description after this live stream. But for right now, what do you think? So now we're opening it up for some Q&A. What kinds of things would you like to talk about? Any questions you want to discuss? Okay, Ceci's saying, what was the type of math problem that you solved in the second example with possible values? Okay, here, let's flip back to that one for a second. So, I abbreviated this a little bit. I got this from one of the other practice tests, one of the other SAT practice tests. So I abbreviated the wording a little bit, but basically, this is testing us on, working with compound inequalities, and it was a little bit of an abstract problem because, we had to find basically a range of values. So yeah, so you might want to kind of scan through some of the practice tests on the SAT the College Board website for some of these inequality type problems. This is challenging, you know, that's why I wanted to bring it up today. But yeah, other questions you want to talk about more? What do you guys, yeah, you guys have some questions for me? Okay, so Bob's asking a good one. Let's see here, Bob. So you've got x plus 4 times 2x minus a. And let's see, what do you have here is equal to 0. And you're wondering how to find a? Okay, that's a good question. So, all right. So what do you guys think? So what would you do to solve this? Any ideas? Well, the problem with this one, Bob, if I can just kind of jump in here, is that, see, when you have two variables, so we have x as a variable and a as a variable, you need actually two equations to solve. Now, if you want to solve for a in terms of x, you know, that's an option, but I maybe need to know a little bit more about this one. But you know, if we were just going to go through the motions here, we could like FOIL it out or distribute. So we could say, you know, 2x squared minus ax. Let's see, what else do we have here? Yeah, okay. Gato is saying x equals -4. Yeah, that's actually one of the solutions. That's exactly right. See, the other solution would be is going to be a equals 2x, because the idea here is that you set each of these factors equal to 0 and solve. That's called the zero product property. So so that's basically when it's in factored form like that, all you have to do is make two equations. X plus 4 equals 0, 2x minus a equals 0, and solve. But I need to know a little bit more about maybe the wording on that one, Bob. So I don't know if that helps you a little bit. But okay, other questions, other things that you guys would like to talk about more? Like how'd you do on the... Okay, CC saying, when do you use the discriminant? Okay, good question. Okay, rational equations. Okay, yeah, so as far as when you use the discriminant, how many solutions? Are you guys with me? I think I'm having a little trouble with the connection. So yeah, so basically use the discriminant when you're trying to find the number of solutions. So, you know, b squared minus 4ac is the discriminant. If you guys know your quadratic formula, right? The b squared minus 4ac is that part that shows up underneath the square root, you know. So basically you use that when you're trying to just analyze the number of solutions. So if this is 0, you're going to get how many solutions? And if it's positive, how many solutions? And if it's negative, how many solutions? Well, if it's 0, you're going to get 1. If it's negative, you're going to get no real solutions. You're going to get 2 imaginary solutions. And if it's positive, you're going to get 2 real solutions. So yeah, so you might want to review the discriminant a little bit. So yeah, so other questions, other things everyone would like to talk a little bit more about. What do you think? So we've talked about, okay, so let's see. So yeah, so somebody was asking about rational equations. So do you have a particular, Kalechi, do you have a particular rational equation in mind that you want to talk about? So, you know, rational just means ratio, right? So like if you had something like, I'll just give you a really basic example. Okay, well here I'll give you a little bit more challenging example. Like say, for example, if it was like this plus this. Okay, let's see. Okay, there's some questions coming in about matrices and vectors. I don't think so much with vectors, but sometimes with matrices, there can be a question about that. Just a real basic question, just either like adding, subtracting, or multiplying you know, matrices, and we can talk about that too. So I'm just making this up off the top of my head, so this might not be the best question, but when you solve rational equations, like what you want to think about is like what's the common denominator, and you want to clear those denominators. So for example, on this one, what could you multiply by to clear the denominators? Any ideas? What do you think? So if you're going to multiply to clear the denominators, what's the common denominator? Any thoughts on that one? So what do you think? What's the common denominator? Well, see here you've got x minus 3. Here you have x plus 3. Here you have x squared minus 9. Okay, Tia is saying x minus 3. Okay, let's see. So we're looking for the common denominator. If I factor this guy over here, see how we're getting x plus 3, x minus 3? Okay, yeah, there you go. So Omo Wyman Agato is saying x plus 3 and x minus 3. Yeah, that's exactly right. So what you would do then is you would multiply through all the terms. You take this common denominator, you distribute it to all the groups there, all the terms. And what that does is it clears the denominators. So then you can go ahead and solve. Now you won't have any fractions. So if I was going to do that, when I distribute here, see how the x minus 3's cancel? So you just end up with x times x plus 3, right? And over here, the x plus 3's cancel. So you're going to end up with 4 times x minus 3. And then over here, both the x plus 3 and the x minus 3 cancel, and you're just left with 8. So now that you've cleared the denominators, you know, it's easier to solve. But the main thing you want to be careful of is you can't divide by 0. So if x comes out to 3 or negative 3, then that's going to be what they call an extraneous root, and you want to just, you know, toss that one aside. So that's not one of the answers. So that's basically a basic overview of just like how to solve these equations, and it's about getting that common denominator and then multiplying through. Okay, let's see. Broth Obama is saying, John and Sally spent 120 hours completing a project. If Sally spent 30 more hours working on the project than John did, how many hours did John spend? Oh, okay. So what do you think about that one? So let's see. So basically, Broth Obama is asking this question. It sounds like a system of equations. So let's see if we can write down what he said and see if you guys can solve this. Okay, and think of other questions you want to ask me. Maybe the more specific you can be, I found that kind of works out a little bit better, because then I can kind of address, what you're asking a little bit better. So, okay, so let's see. So we've got, okay, so let's see. So John and Sally spent 120 hours completing a project. So let's just write that down, 120. And Sally spent 30 more hours than John, right? So basically, if you think about this, it's like, here's Sally's hours, here's John hours, and they add up to 120. But Sally spent the number of hours that John spent plus 30 more, right? So, okay, so then Bob says, I got 45. And yeah, isn't that just a system of equations? Yeah, you're right. Okay, very good. So the thing is, when you solve these systems of equations, you know, you've got a couple options. And we did earlier, we talked about substitution, but let's maybe rearrange this one so we can talk about elimination. So say, for example, if I subtract j from both sides of this equation, we get s minus j equals 30, right? So now if we were to add these two equations together, what do we get? 2s. The j's cancel. We get 150, and s is equal to 75, right? So now if you put 75 back in over here for s and solve for j, you get 45, or same thing over here. If you use this original equation, you get 45. So yeah, so basically that's substitution, elimination. Systems of equations is definitely important on the SAT, so you might want to review that if you're studying. But other questions you want to talk about, let me look back in the chat here. So yeah, so other things you want to ask about. Somebody was asking about an outlier and probability. So I think when you're talking about outliers, like, you know, I can tell you a little bit about that. Like if you've ever worked with the box and whisker plots, have you guys ever graphed the box and whisker plots? So the idea is, like, if you were to take this range here, this what they call the interquartile range. Okay, so it's basically the third quartile minus the first quartile. And if you multiply that by 1.5, okay, and if you add it to this third quartile, okay, if there's points that are further to the right of that point, that's considered an outlier. Or if you subtract 1.5 this interquartile range from the first quartile, any points that are lower that, those are considered outliers. So that's box and whiskers. But, you know, basically when you're just looking at the data, if you see a point that's like way, you know, higher than all the rest or way lower than all the rest, you know, typically that you can say that's an outlier. Okay, so Bob's asking about, can you explain standard deviation? Okay, so let's see. So standard deviation. Yeah, sure, definitely. And the difference between greater deviation and less. Okay, well, the only thing I really can maybe speak to as far as deviation, standard deviation goes is basically this. Okay, so the standard deviation is an idea. Okay, not an idea, but it's an indication of how spread out the data points are from the average, from the mean, right? So the larger the standard deviation is, the more the data points are going to be spread out from the mean. So like an example, and the smaller, the closer they are to the mean. So for example, if in your test, so Kalechi is asking about the rational equations. Yeah, you might want to check back to that one that we were doing just a little earlier, the rational equation one. That's a good example. Maybe review that one. But basically, Yeah, so for example, if you took a quiz like in your class, and say for example, everybody got like 7, 7, 8, 8, 8, you know, just an example. So you can see here, like, you know, everybody's basically getting right around a 7 or an 8. Okay, so you can see this one's going to have a very small standard deviation, as opposed to, like, say another class took the same test and like somebody got a 1 and somebody got a 5 and somebody got a 9, somebody got a 10 and somebody got the extra credit and they got an 11. This is going to have a much higher standard deviation. Now, as far as calculating the standard deviation, you know, you can use your calculator for that if it's a calculator section, but I think as far as the SAT is concerned, you're probably not going to have to do that just because of the time constraints. They might just ask you more generally, like which one's going to have a larger or smaller standard deviation. So I do talk about this in the course that I mentioned earlier if you guys are interested in that, but it's a little bit much to go into right now. So let's see, other questions. Somebody else had a question about a circle. Jake was asking about the circumference of a circle is 24 pi meters. What is the area? Okay, let's see. So see if you guys and gals can figure out this one. So let's see, what was that question again? So let's see, it's circumference is 24 pi meters, and they're asking what the area is. Yeah, I mean, this is just kind of a pretty good question, just a good introductory question. What do you guys think? So any ideas about how to find the area? Okay, Bob says 144 pi. Okay, is he right? Well, again, you know, I always like to kind of draw a diagram, you know, and what's the formula for circumference? 2 pi r, right? So now if you just substitute, right? Okay, divide by 2, okay? So that's right. So that means the radius is 12. Okay, very good. And so then what's the formula for the area of a circle? Pi r squared, right? So then all you have to do is put that 12 in for the radius, square it, times pi. So it's going to be 144 pi meters squared. So yeah, so just some formulas you want to memorize, you know, your circumference formula, your area formula, you know, those are going to be important. So yeah, so other questions, other things you guys want to talk about? Okay, yeah, Bob is really sharp. He's quick on these, so that's good. But yeah, with practice, you guys all get quicker too. So have you guys been taking the practice tests that have been released by the College Board? Let's see. Have you guys been taking those practice tests? I think there's 8 of them up there now. They've got 8 practice tests, and those should be pretty representative of what the actual test is going to look like. So, you know, you can go on there and sizing. Okay, yeah, you've taken those. Yeah, that's a really good way to practice. You know, take those tests and go through them and see which ones you're missing. You know, again, these courses that I mentioned earlier that you can check out, they talk about a lot of the underlying concepts. So. Okay, let's see. Broth Obama is saying, can you explain a problem with the radians? Okay, so a problem with radians. Okay, so let's see. So a problem with radians. So let's see. So when we're talking about radians, the main thing to know with radians, okay, just to make it real simple here, is that pi radians is equal to what? 180 degrees, right? Pi radians is 180 degrees. So whenever you see pi, you can replace it with 180 degrees. So if they say, you know, 5 pi over 6, you can put 180 in place of pi and simplify 150, right? So, yeah, so that's basically it. So let's see. Yes, I have. Can you make a video on SAT 5 through 8 math, please? Bob Gill says, what happened? Yes, you know what? Unfortunately, I don't know. You know, it's like people are calling me right now. I thought I put my phone on do not disturb, but apparently it's not. But yes, I apologize about that. So yeah, so other questions. I don't know if this answers your question about the radians, but like, you know, for example, oh, it says stream offline. Okay, huh. It says I'm online right now. I think it just got interrupted. The stream got interrupted. Maybe try hitting refresh. Okay, so it's back on. Okay, great. Okay, Kalechi is saying rational equations and expressions. Well, yeah, I talked about that one a little bit earlier. So when you talk about rational expressions, you know, that's like this guy over here that we were doing earlier. So if you go back to that, you can kind of analyze that a little bit further. But it's all about clearing the denominators when you're solving those rational expressions. Okay, yeah. So let's see. So other questions. So yeah, so other questions you want to talk about. I notice you guys are starting to jump in and help one another. That's the key. So if somebody wants to maybe help that person that was asking about the rational equations, feel free to do that. But other questions that you want to talk about, other things you want to talk about regarding the SAT. Okay, so study site's asking about, what suggestions we have about timing in the SAT math. As far as timing goes, it's very similar to like the SAT in the sense that, the easier questions tend to be at the beginning, the more difficult questions tend to be near the end. There's 2 sections, but like for each section, it tends to start easier. So you definitely want to work faster in the beginning to save yourself some time for those later questions. So yeah, so that, I don't know if that helps you at all, but yeah, don't overthink the ones in the beginning, but then don't take for granted the ones a little bit later because they tend to be a little bit more steps, so you want to save some time for that. So work faster in the beginning, and then you'll have time for those tougher ones. Okay, so other questions, other things you want to talk about. Let's see. Do you think the ACT math is easier than the SAT math? A lot of people are telling me that they do think that the ACT math is easier just because you can use your calculator throughout the whole entire test, whereas the SAT, some of it's calculator, some's not calculator, some's free response, whereas the ACT, it's all multiple choice, it's all calculator. So a lot of people tend to find that ACT to be a little bit easier than the SAT. So yeah, that's my opinion. That's what other people have told me as well. So let's see, Bob is asking, is there some type of quadratic equation thing for cubic equations? There is a formula for that. I remember learning about this when I was in school, about a formula for cubic equations. It's quite a large formula. It's not as nice and easy to work with like the quadratic formula is, but you're not going to have to worry about that for the SAT. But yeah, good question nonetheless. Sai is asking, how often do you make these live streams? I kind of just want to have the time. I'm usually pretty busy working with students. So sometimes when I have some time and I know a test is coming up, I'll talk about the course that I put together to, promote that, of course, and then, just jump on and try to help some of my subscribers, prepare and that kind of thing. So yeah, let's see. Does your program have every concept you need to study, or just 39? Well, it's Barack Obama. It's just basically 39 concepts that are basically important and recurring concepts. There's always like a few little problems that maybe show up on one test and not the next test, but those 39 were ones that I noticed came up over and over and over again throughout the tests that they've released, and so that's why I focus on those. So I mean, depending on where you're at, if you're like you're like at 750 or whatever, you probably don't need the course. If you're at 400, something like that, and you're trying to boost your score, you're on the low end, then this would really definitely help you, the course, go over those key concepts. So yeah, so I think Kalechi is asking more some mole questions, more about science type questions. You won't have to worry about that for the math section of the SAT. And then Jake's asking, can you go over using proportions to solve problems? Yeah, so when you talk about proportions, what's a proportion? So yeah, that's a good question, Jake. So here, let's talk about proportions. See, basically a proportion is what? It's a ratio equal to another ratio, right? So, for example, if you can, let's say, for example, if you're able to make, let's say, 3 dozen cookies in 15 minutes, something like this, it's like, how many cookies could you make in like 4 hours? Okay, like this. So a proportion is just a ratio equal to a ratio. But when you're looking at this question, you see how I kind of put a little twist on it? I said, how many cookies can you make in 4 hours? Well, notice over here we've got minutes. Over here we've got hours. Yeah, and Bob, you're right about the 48 dozen, but if you want to find out how many cookies, there's how many in a dozen? There's 12 in a dozen, right? So 12 in a dozen. So you got to multiply so you got to multiply those together. So you want to make sure when you're doing those proportions that the units are the same. So to answer your question, Jake, like if you have dozens per minute, we're going to calculate dozens per minute. So like here, I would probably convert this into, what is this? 4 times 60, 240 minutes, right? Like that. Then when you get your answer over here, you're going to actually get the number of dozens of cookies. Then you have to convert that into just actual cookies. Or what I could do is I could say, well, a dozen is 12, so I'm going to convert this to 36 cookies. right? So now when I cross multiply, you can cross multiply and solve this. You could say 15 times x equals 36 times 240, and then you just divide both sides by 15, right? And then you've got it. So yeah, so basically, let's see. So other questions, let me look back in the chat. I know we've kind of had a little bit of some interruptions on this live stream. I apologize about that. Sometimes it gets a little bit crazy, but let's see what other questions you have. So Study Site's asking, can you make videos for the SAT practice test math 5 through 8? What you might want to do is, Khan Academy has the solutions online. So if you take the tests, they have the solutions, like there's like an online way of taking the tests. They have the solutions. You can check right there for those solutions, and they also have the answers as well. And you can also print out some of the steps too that they released for those tests. So I probably recommend checking that out. And Jake's also asking, let's see, what books do you recommend for studying for the SAT math? Princeton usually puts out a pretty good book. You could check that one out. That seems to be kind of a middle of the road, but there's like Princeton, Kaplan, Barron, but maybe Princeton would probably be a good place to start if you're looking for extra problems and whatnot. Let's see. Bob was asking about inverse proportions. Oh, Bob, can you tell me more about the inverse proportions? What did you mean when you meant when you said that? So inverse proportions. Maybe tell me more about that. And let's see, Barack Obama, how would I improve on problems that, where you have to come up with an equation? Ooh, that's a good question. So yeah, so the thing is, you want to be able to translate those word problems into equations. So it depends. It depends on the problem, whether it's I mean, is it like the one you were asking earlier, where you were asking about the system of equation one with the 2 ages or the 2 amount of work hours? Yeah, let's see. That's a tough one. A lot of it's just practice, practice picking out the important information. Let's see. Which of the following is equivalent to 9 raised to the power of 3 over 4? Okay, let's look at that study site. Let's see if we can do that problem. So let's see. So 9 raised to the power of 3 over 4. Okay, let's see. And we're wondering, what's that equal to? Is it 3 square root 9, 4 root 9, root 3, 3 root 3. Oh, I see what you're saying. You're saying, okay, wrong question. So you're saying 9 to the 3/4 power. Okay, this is interesting. Here, let me grab another sheet of paper. So is everyone familiar with rational equations? Not rational equations, and rational exponents. Rational exponents. Rational just means fractional, right? So it's a fractional exponent. So 9 to the 3/4 power. Well, here's the thing. Let's see. Bob says square root of 9 to the 3rd. Okay, good. Yeah, good question. So basically, yeah, this is a good question. So when you look at 9, 9 is 3 squared, right? Okay. And then what do you do when you have a power to a power? So you multiply, right? So this is 3 to the 6/4, which is really equal to 3 to the 3/2, right? Which is really like, let's see, that's really like 3 cubed, but then you're taking the square root. So the key here is really remember that the denominator is the root, and the numerator here is the power, okay? But you can simplify, oops, I meant to put this 2 over here. So yeah, so basically what you can do is you can pull out a 3 here, so this is going to be 3 square root of 3. So I don't know, you want to check that again. So basically what did I do? I said, let's go ahead and write 9 as 3 squared, and a power to power u, multiply, right? Then I reduce that fraction, and then just remember that this denominator right here, that's the root, that goes there, okay? And then the numerator, that's the power, that goes there, and then you can simplify from there. Okay, so that helped you, study site? Okay, great. Okay, so yeah, there's more than one right answer, Bob. Sometimes you just have to look at the multiple choice and pick the best one, but this is a pretty simplified version, but sometimes they might put it in a slightly different form, so you have to check to see what the equivalent, the equivalent ones would be. Okay, so other questions. I think we only have about 3 people with us at the moment, so kind of a smaller group. I think people kind of jumped on and then kind of jumped off, but other questions for those that are here that maybe you want to ask me some more questions. So maybe what I'll just say in the moment while you're thinking of those questions is, if you're interested, I've got a link in the description to this video so you can check out my 2 courses. I've got a huge ACT math review video course, and that goes through 65 concepts that you want to know for the test, and a huge SAT math review video course, and that goes through 39 concepts that are important. So this goes through kind of like the underlying important things you want to know. So check those video courses out. There's 3 free previews, so if you go over there and just want to see what it's like and see if it's right for you, you can still benefit from those 3 free previews on both those courses. So yeah, go ahead and check out the link in the description and see if that's something that you're interested in. But yeah, other questions, other things you want to talk about right now just on this live stream. I know the test is coming up for a lot of students, so that's why I thought I'd jump on here. Okay, so Jake is asking a question here. Let's see, Jake. We've got 3x minus y equals 12. And let's see, hold on a second. But a lot of technical difficulties today, right? Okay, sorry about that. So, and then what is, this is 8 to the x power, divided by, 2 to the y. Oh, okay. Yeah, this is a common question. Yeah, it sounds like you're pulling this from one of the previous tests. Okay. Bob says 2 to the power of 12. He's using to solve his homework. Yeah, that's right, Kalechi. Okay, yeah, but just in general, just to kind of mention something to you guys, is that this is just testing you on the rules of exponents. So if the bases are the same, right, and you're dividing, then you subtract the exponents. Yeah, so Bob's saying just write it as 2 cubed, right? 8 is 2 cubed. And then over here like that, and then power to power you multiply, right? So that's going to be 2 to the 3x. And then when you divide, what do? You subtract, right? Okay, and then okay, so then what you have here now is you've got 2 to the 3x minus y power, but since that equals 12, you can write that as 2 to the 12th. So I hope that helps, Jake. But yeah, basically the key is to get the bases the same. And then know all your rules of exponents. So like when you multiply, you add the exponents. When you have a power to power, you times, and then when you divide, you subtract. So yeah, so other questions, other things you guys want to ask me? Any other questions? So what do you think? Oh, Kalechi, sorry. Okay, you were asking what's the difference between permutation and combination. Okay, that's a good question. So, okay, so are you guys familiar with this notation, NPR and NCR? Are you guys familiar with this? So, permutation, the order matters. Combination, the order doesn't matter, right? So, the example would be like this. Like, say for example, you have like, say there's 10 people in your class. Okay, it's a small class, right? And say you're going to pick a president and a vice president. Does the order matter or does it not matter? Does the order matter or does it not matter? So 10 people in your class. Yeah, you can use it on your calculator too. That's a good point, Bob. But let's just see if we can get the setup. So do you think like the order matters? Like if you're going to pick, yeah, or you can do the factorial thing by hand. That's true. So the thing is though, so with permutations, the question was, what's the difference between combinations? Okay, so yeah, so basically the permutations, the order matters, combination doesn't matter. So to go back to our example, if there's 10 people in your class and you're going to pick a president and a vice president, the order matters. You want to use the P for permutations. If you were just going to pick 2 co-captains out of 10, right, then you're going to use the combinations 10C2. And just like Bob was saying, you can just type this in on your calculator, 10P2, and find out the number of ways of picking a president and vice president. Over here, 10C2, okay, you're going to be finding out the, the number of ways of just picking 2 people where the order doesn't matter. So again, I think I'll just kind of leave it at that. You can use your calculator on these types of problems to solve. So does that answer your question, Kalechi? So, okay, so other questions, other things you want to ask about? Of course, the thing is that, with the ACT and the SAT, that what are they testing us on? Basically, pre-algebra, algebra, algebra 2, right? Trig, geometry, and so there's a little bit, from each of those different areas. So, let's see, Brothabam, I missed your question. Let me go back. Let's see. Try to get everyone's questions if I can. Oh boy, where I lost that. Which word? Oh, how would I improve on problems where you have to come up with an equation? Is that the one you were asking about? Is that the one you meant? So yes, I mean it's hard. That's a difficult one to. Okay, Bob's asking about Sohcahtoa, and okay. Oh, I guess maybe I didn't see that one. Can you ask me that question again, Barack Obama? How to use trigonometric ratios with the unit circle? Okay, so you're asking about the unit circle, trig ratios. Well, that's a big topic. I don't know if I can really explain that too much. I mean, you can check. I've got a video on that. It's all about the unit circle, master the unit circle, on my YouTube channel, Mario's Math Tutoring. I'd probably go over there. That's probably got a better explanation than I can do for you right now, just because it would take quite a bit. Yeah, so those are the basic ones, Bob. Like, let's see. Zayad is asking, what book should I buy if I'm done with the official SAT tests? Well, that's a good question. You know, you can go over to, like, it depends on how advanced you are. Like, if you're really advanced, like Barron's usually has more challenging type problems. If you're kind of middle of the road, I would say like Princeton or Kaplan, you know, one of their study guides. So I'll probably check those out. Bob says College Panda is good for math. I'll have to check that out. I've never seen their stuff. Okay. All right, some good suggestions. Yeah, very good. So let's see. So other questions, other things you wanted to ask me about? Oh, you were asking about the Sohcahtoa. Okay, so yeah, so here we'll do some examples with the Sohcahtoa. Okay, Zayad, you're welcome. Okay, good test taking tips. You know, that's a good question. You know, there's whole classes devoted to these test taking tips, like, you know, how to take the answers and back substitute, or how to eliminate ones that you know that are not right. And, you know, there's a whole like strategy behind like kind of like solving the problems without actually having to solve the problems. And those are definitely valuable. You know, like some of these problems, like remember that question that I think Jake was asking about the system of equations earlier. Sometimes you're better off just back substituting the answer in and checking. You know, sometimes that's faster, but you're going to have to kind of get that down from experience to see if you're better off trying to go ahead and solve it or just trying to take those answers and back substitute. So, but as far as just solving some Sohcahtoa type problems, like say, for example, this is 3 and this is like 27 degrees and this is x. Like, how would you solve for this missing side right here, x? So here we're talking a little bit about the sine, cosine, and tangent ratios, right? So what do you think? What would you do to solve for that missing side? Would it be a sine ratio, cosine, or a tangent ratio? What do you think? Bob says sine of 27 equals 3 over c. Let's see. So basically you pretend like you're standing at the angle at this vertex here. This is the opposite side. That's the hypotenuse. So see opposite hypotenuse. That's sine. So sine of 27 degrees equals 3 over x. And then what you can do is you can cross multiply if you want. This is one way to do it. So x sine of 27 equals 3 times 1, which is 3. And then divide both sides by sine of 27. And that's going to be your answer right there. So yeah, so you really want to know these ratios, the sine, cosine, tangent ratios. Other questions. Yeah, other things you want to talk about? Other things that you... Does everybody know the equation of a circle? I mention this problem all the time because, you know, a lot of times students, they forget this one, but it's a super easy question to get right. So I'll just give you an example. So if there's other questions, go ahead and put them in the chat. We'll see if we can get to some of the questions and before we finish up this live stream. But let's see what other questions you guys have. But I'm writing down an equation of a circle. Can anybody tell me what the center of the circle is and what the radius of the circle is? Radius is 4, Bob says. Okay, is he right? And the center is at positive 3, negative 4. Okay, what do you think? Is he right? So what do you think? So when we're talking about the equation of a circle, okay, Barack Obama says yes. Okay, he's right. Kalechi says no. Okay, what do you think it is, Kalechi? Is it, so just a kind of a refresher here, if there's only one thing that you memorize out of this entire live stream, remember this, because this is an easy one to get right. The equation of a circle, right? So here's the center here, it's HK, and this is your radius. So you can see to get from 16, that's r squared, right? We actually have to take the square root, so the radius is going to be 4. And then with the center, see how this is x minus h, so it's actually positive 3. negative 4, and the radius is going to be the square root of 16, which is 4. So yeah, so basically you want to take the square root to get the radius. And oh, Bob is asking, sometimes you have to complete the square for circle equations. And Kalechi says, how do you deal with this problem with a three-dimensional circle? Okay, you're talking about like a sphere. Okay. And yeah, so you're not going to really have to solve for like you're not going to have the formula for a sphere on the SAT, so I wouldn't worry about that one for right now. So we'll leave that for another another discussion. But as far as completing the square, that's an important skill. It's definitely something you want to understand. Sometimes they'll give you an equation that looks something maybe like this. Say, for example, x squared plus 2x, let's see, plus, let's see here, plus, let's say this is y squared plus 6y plus 4 equals 2. Okay, I'm just making something up. So what you would have to do is you have to complete the square, to put it in the standard form of the equation of a circle, so you can identify the center and the radius. So yeah, so that's definitely important, something important to understand, completing the square. Anybody want to try to solve that one and check that with Bob and see if you guys got that right? Okay, so he's talking about, yeah, b over 2, the quantity squared. Yeah, that's exactly right. You got it. So what do you guys think? So yeah, so basically what you would want to do is you'd want to move these constants to the other side. So I'm going to subtract the 4, that's negative 2. And then over here, let's see, we've got, okay, so now we're going to, study site says I have a lot of questions to ask, but I can type them because it's so involved. Oh, it's a diagram. Yeah, those diagram ones hard to describe on a chat. Okay, so let's see. So basically what we want to do, Bob was saying you take half of this middle coefficient, so half of 2 is 1, and you square it, which is 1. But if you add it to the left, you have to add that 1 to the right to keep it balanced, right? Same thing over here. You take half of 6, which is 3, and square that, which is 9, but you have to add 9 to the other side to keep it balanced. Then what you want to do is factor this, and same thing over here, you want to factor this, and then combine like terms over here. So now you can see the center is going to be what, and the radius is going to be what. So I talk about completing the square in the courses. You can check that out if you want to learn more about the completing the square process. We do a bunch of examples. But here you can see the center is going to be at -1, -3, and the radius is going to be the square root of 8. And you can simplify that down. Okay, Kalechi, how do you graph a quadratic equation? Yeah, Bob, square root of 8. So when you say quadratic equation, can you be more specific? So if you guys can be more specific with your questions, I'll be able to help out a little bit better. If you have a more specific question. Quadratic equations, you know what quadratic equations are? Quadratic equations are equations that have that squared, right? Yeah, you can graph it on your calculator. That's a good suggestion. Yeah, you can always graph them on your calculator. But yeah, that's kind of a big topic. I need a little bit more specific on that. Yeah, you can find the vertex and find the zeros. 2x squared minus 4x plus 6. Okay, let's see. 2x squared minus 4x plus 6. You wanted to graph this? Well, okay, so this one here is what they call, yep, Bob's saying a y-intercept of 6. That's right. And how do you find the vertex? What's the key to finding the vertex of this parabola? Well, yeah, negative b over 2a, that's right, for the x coordinate. Okay, good. Oh, Bob, you're really sharp. You got this down really good. Okay, and their parabolas going up or downward depending on their x value. Yeah, so basically this coefficient here, a, if it's positive, it means it's opening up. If it's negative, it's opening down. That's exactly right. You guys are on this. But to find the vertex, you can use the completing the square process. That's one way to do this. Okay. But it's easy just to use this formula here, negative b over 2a. Okay, so what you're going to want to do is take the opposite of b, so the opposite of negative 4 is positive 4, over 2 times a, which is 2, right? So that comes out to what? That's 1, right? So then move this up here a little bit. So if you put 1 back into your equation here, you're going to get the y-coordinate of the vertex. So that's 2 minus 4 is negative 2, plus 6 is 4. Okay, so we're looking at our vertexes at 1, 4. Okay, and the y-intercept is at 6, like Bob said over here, so 5, 6. And then this is the axis of symmetry right through the x-coordinate of the vertex. So if you take the mirror image of that y-intercept point, you've got another point right there, and you've got your graph. So just kind of a rough sketch there. Okay, so you guys have a lot of great questions. So a lot of great questions. So I think what I'm going to do now, okay, is I'm just going to kind of mention a couple quick suggestions. So one is, if you haven't checked these out yet, go ahead and check it out in the description, the huge ACT Math Review video course and my huge SAT Math Review video course. There's 3 free previews over there, so you can kind of see what it's like and see if that's something you're interested in. I highly recommend them if you guys are in the middle. If you're somewhere at, getting a really high score already, then, these would be kind of more review. But if you're on the lower end of things and maybe you kind of forgot some concepts, or, there's a lot of things that you need to review, these courses are going to be excellent. So definitely check that out. And the other thing is that if you guys are interested, after I stop this live stream, if you want to continue to help each other in the comment section of this video, that might be a good resource for you guys. You can, kind of ask each other questions and help each other out. So I definitely recommend that. But other than that, thanks for joining me today. And if you haven't subscribed to the channel, if you're interested, I've also got tons of videos on my Mario's Math Tutoring YouTube channel. So check that out for more help, if you're looking for some help in your math class or help with ACT, SAT. And I think if you're interested in online tutoring, you can also reach me for that. If you're interested in doing an online session, we can set that up. You can contact me through my website, mariosmathtutoring.com. And I think that's about it. So great job. Thanks for being here, and good luck when you take the test. If you need to reach out to me, you can do so. Otherwise, I'll talk to you next time.